My research is in nuclear astrophysics, so we study how stars explode, how elements were made in the universe, and that kind of stuff. Undergraduates in my group do a variety of different projects. So recent examples include designing a charged particle detector for experiments here at the lab. Then another student is now designing a frame to hold that charged particle detector. Other students are analyzing data from nuclear physics experiments that we've done here. And others I've worked with on modeling exploding stars. So trying to reproduce the explosions that happen in space so that we can assess the impact of the experiments that we do here at the lab.
I interact a lot with undergraduate students, mostly through the SPS, the Society of Physics Student. I'm the advisor of SPS. So we have a weekly meeting that's usually on Tuesday at noon. Have a pizza meeting, so get all the SPS members getting together, talk about all kinds of things related to physics. And also we do a lot of planning for university-wide outreach or activities related to physics. Any student who is interested in research, they are guaranteed to be able to do the research they like in our department in summer, and also it's paid research. My labs mostly focus on electronic materials and devices. So students in my group, for example, undergrad student in my group, they learn how to synthesize the electronic materials, learn how to fabricate these memory devices, and they learn the basic physics under the devices and how that works and why they work.
If an undergraduate major is interested in computing, has corresponding skills and wants to improve his skills, that is a good starting point to work. And usually, I mean, they don't write their own codes or do the equations, but they do a set of calculations. They have to make the images going with it, and then we try to interpret the images. They all learn how to be very focused and also inquisitive, because that is the difference between like an experiment in the lab. On a computer you can experiment a lot more. You can change parameters, you see what happens if you go outside a range and see if something interesting in your physical system which you simulate, something interesting is happening. So being inquisitive is important.
We have undergraduates who do experimental projects at the accelerator here on campus. We have undergraduates who do experiments off campus, thanks to our collaborations with Jefferson Laboratory and the Relativistic Heavy Ion Collider at Brookhaven National Laboratory. And then we have undergraduates who do theoretical work, where they do computer modeling of nuclei or neutron stars, and who develop their mathematical skills working out the math for nuclear physics too. Physics theory is a very useful thing to study because it helps you develop the ability to analyze a problem, to break it into smaller pieces, to build a model that helps you to understand what's going on, and to think rigorously about the world around you.
Some have done experimental design projects where they do some basic calculations to get an idea of the count rate and detector requirements for an experiment that we might want to do in the future and see if that is feasible. Some other undergraduates have analyzed data that was taken previously and needs to be brought up and completed to the level where it's published. So if an undergraduate student shows initiative and wants to get involved at a higher level in working with a professor, especially on a research project, that opportunity is there and in fact is encouraged by the department. The accelerator laboratory is a particularly nice opportunity for undergraduates to get involved in research. They can become operators of the accelerator, which makes them useful for assisting lots of people, graduate students, outside researchers, and others with their experiments, as well as doing their own projects.
I think Ohio University's Physics and Astronomy department is a great place to come and study physics because it's small enough that we have a community where we look out for our students and try to make sure that they are achieving their full potential. But it's large enough that you have a wide range of research options, and you can probably find something that you're interested in doing no matter what your particular skills and enthusiasms happen to be. I think that makes it a great place to be an undergraduate because you can work on interesting problems and at the same time feel like you're part of a community that cares about your development as a person.